Define set. Explain types of set. A set is a well-defined collection of distinct objects called elements. The objects in a set can be numbers, symbols, or real-life items. Sets are usually represented using curly brackets. For example, A is equal to set 1, 2, 3. Sets are classified into different types such as finite sets having limited elements, infinite sets having unlimited elements, empty set having no elements denoted by phi, universal set containing all elements under discussion, and equal sets having exactly the same elements. The number of elements in a set is called its cardinality and is denoted by modulus of A. Explain subset and power set. A set A is said to be subset of set B if every element of A is also an element of B, and it is written as A subset of B. If A is a subset of B but not equal to B, then it is called proper subset, written as A subset of B. Every set is always a subset of itself, called an improper subset. The power set of set A, denoted by P of A, is the set of all possible subsets of A. If a set has n elements, then its power set contains 2 raised to n elements. Explain set operations. Set operations are used to combine or compare sets. The union of two sets A and B, written as A union B, contains all elements that belongs to A or B, or both. The intersection of A and B, written as A intersection B, contains only the elements common to both sets. The difference of two sets A minus B contains elements that are in A but not in B. The complement of a set A, written as A complement, contains elements not present in A but belonging to the universal set. These operations are often represented using Venn diagrams. State the principle of inclusion-exclusion. The principle of inclusion-exclusion is used in counting problems to avoid double counting of elements. For two sets A and B, the formula is modulus of A union B is equal to modulus of A plus modulus of B minus modulus of A intersection B. For three sets, we add the sizes of individual sets, subtract the sizes of all pair-wise intersections, and then add the size of triple intersection. This principle is widely used in surveys probability types of problems. Define function. Explain basic terms. A function is a rule that assigns each element of one set called the domain to exactly one element of another set called the codomain. It is written as f is to a to b. The range of a function is a set of actual output values obtained from the domain. Functions can be represented using formulas, tables, or mapping diagrams. The main idea of a function is that one input gives exactly one output. Explain types of functions. Functions are classified based on how elements are mapped. An injective or one-one function maps different elements of the domain to different elements of the codomain. A surjective or onto function ensures that every element of the codomain has at least one preimage in the domain. A bijective function is both injective and surjective, and such functions have inverses. A many-one function maps two or more elements of the domain to the same element in the codomain. A function is invertible if and only if it is bijective. Explain composition and inverse of functions. The composition of two functions f and g is defined as g into f of x is equal to g of f of x, meaning we first apply function f and then apply function g to the result. The order of composition is important. The inverse of a function reverses the effect of the original function and exists only if the function is bijective. If f has an inverse, then f of f raised to minus 1 of x is equal to x. Inverse functions are useful in solving equations and reversing processes. Define relation. Explain representation. A relation from set A to set B is defined as the subset of the Cartesian product A cross B. It consists of ordered pairs AB, where A belongs to capital A and B belongs to capital B. Relations can be represented in different ways, such as listing ordered pairs using a matrix representation or drawing a directed graph, digraph, and identity relations on a set contains all ordered pairs of the form AA. Explain properties of relations. A relation on a set may satisfy certain properties. It is reflexive if every element is related to itself. It is symmetric if whenever AB is in relation, then BA is also in relation. It is antisymmetric if AB and BA together imply that A equals to B. It is transitive if whenever AB and BC are in relation, then AC must also be in the relation. These properties help classify relations. Explain equivalence relation and partial order. An equivalence relation is a relation that is reflexive, symmetric, and transitive. It divides set into disjoint subsets called equivalence classes, and these classes form a partition of the set. A partial order is a relation that is reflexive, antisymmetric, and transitive. A set together with a partial order is called a partially ordered set or poset. Partial orders are usually represented using Hasse diagrams.